It was a crisp autumn evening when Alex, a young mathematician with a mind that constantly sought connections between the abstract and the tangible, sat down at his desk. The desk was cluttered with papers scrawled with equations, matrices, and vectors. Symbols that to most would seem arcane, but to Alex were the language of the universe itself. Alex's latest obsession was eigenvalue problems. These mathematical enigmas had whispered their significance to him during a lecture, but he felt their story ran deeper. He wanted to understand not just the mathematics, but the essence, what these problems meant for life, for nature, for the world around him. An eigenvalue problem begins simply. Take a vector, apply a transformation, a matrix in mathematical terms, and see what happens. Often, vectors twist, turn, and stretch in unpredictable ways under such transformations. But sometimes, miraculously, a vector stays on course, its direction unchanged. It may stretch or shrink, the eigenvalue determining by how much, but its essence, its orientation in space, remains intact. It's like life, Alex thought, scribbling furiously in his notebook. We're all vectors subjected to transformations, education, relationships, challenges. Some forces change us fundamentally, but others stretch or shrink us while leaving our core direction intact. He paused, staring at the matrix he had been analyzing. Some transformations were benign, preserving the vector's integrity. Others were annihilating, reducing it to the zero vector, a mathematical ghost of its former self. And then there were those that flipped the vector's direction, turning it into its opposite. Alex began to see eigenvalue problems everywhere. The rustling trees outside his window were vectors transformed by the wind. Some branches swayed but stayed rooted, while others snapped. The ocean waves he had seen on his recent trip, their rhythmic motion echoed eigenfunctions in the infinite dimensional spaces of fluid dynamics. Even human interactions, he realized, could be seen as transformations. His friend Clara, a violinist, once explained how different pieces of music changed her mood. Some compositions amplified her joy, others subdued her sadness. "You're describing eigenvectors of the soul," Alex had joked, but now he wondered if there was truth to it. One transformation haunted Alex, the annihilation of a vector, its reduction to nothingness. This was the fate of eigenvectors, corresponding to a zero eigenvalue. What did it mean to vanish? He thought of societal pressures that could suppress individuality, or internal fears that could erase ambition. Could understanding these annihilating operators help prevent their effects in real life? But there was hope too. Not all annihilation was destructive. In physics, quantum states vanish and reappear, intertwined in the dance of probabilities. In art, a blank canvas, an annihilated state, was the precursor to creation. Some transformations, Alex realized, reversed vectors. These were reflections, a simple yet profound operation. In life, they were the moments of reversal, a change of heart, a new perspective, a revelation. Alex thought of his mentor, Dr. Rowan, who once described failure as a necessary inversion, a force that flipped one's trajectory but propelled growth nonetheless. Then there were the diagonalizable matrices, transformations that, in the right coordinate system, became as simple as scaling each dimension independently. These, Alex mused, were like the moments of clarity in life, when complexities untangled and everything aligned. In such moments, the world's infinite intricacies seem reduced to something manageable, comprehensible. Beyond diagonalizable matrices, Alex explored other forms that held profound insights. The Jordan form, for example, revealed the subtleties of near-degeneracies and transformations. It was like understanding imperfections, moments when life didn't entirely align, but patterns still emerged, layered and intricate. These forms offered hope for even the most complex problems, where simplicity could still be found hidden within apparent chaos. Then there was the Schur form, which transformed matrices into upper triangular ones while preserving their eigenvalues. Alex thought of this as distilling complex situations to their essence, step by step, without losing the core truth. It symbolized the gradual revelation of order, where each layer peeled back brought clarity and direction. Even singular value decomposition (SVD) fascinated Alex. It generalized eigenvalue problems to non-square matrices, breaking down transformations into rotations and scalings in orthogonal directions. To Alex, this was the ultimate representation of harmony. Every action, no matter how complex, could be understood as a composition of simple, pure movements. SVD embodied the hope that even the most convoluted problems could be unraveled into comprehensible and beautiful truths. These matrix forms, Alex realized, weren't just mathematical tools. They were philosophies of problem solving. They showed that complexity didn't have to be overwhelming. It could be broken into patterns, understood, and addressed with elegance and precision. As Alex's thoughts spiraled deeper, he marveled at how eigenvalue problems connected disparate fields. In quantum mechanics, they described energy levels of atoms. In structural engineering, they predicted vibrations in bridges and skyscrapers. In machine learning, they powered principal component analysis, reducing vast data sets to their essential patterns. Everywhere Alex looked, eigenvalues and eigenvectors were silently at work, shaping reality. That night, as Alex stood by the window, staring at the stars, he felt a profound connection to the universe. Each star, a point of light, seemed like an eigenvector, a direction in the infinite expanse of space, its brightness scaled by some cosmic eigenvalue. The heavens themselves, perhaps, were the result of a grand transformation, a matrix too vast for human comprehension. And in that moment, Alex realized that the beauty of eigenvalue problems wasn't just in their mathematical elegance. It was in their ability to reveal the underlying order of the world, to bridge the abstract and the real, and to remind us that, even in the face of transformation, some directions remain true. The journey through the nexus may end here, but the exploration is endless. If curiosity stirs within you, let's continue to unravel the threads together. Like, share, and subscribe to keep the connections alive. Until we meet again, question boldly, connect deeply, and explore endlessly.